Hello, if you've just come over from Deepak's interview with me, this is the slideshow. I wanted to go ahead and give a full presentation. We were able to talk about some of the interesting parts of it on Deepak's interview, but I wanted to go through and try to get at some of the details, et cetera, that we weren't able to address, and I hope you'll enjoy this. All right. So basically, we went through a little bit of my origin, on the show, and the fact that I was a software engineer for a decade, that I had a lot of nieces and nephews that kind of got me interested in neuroscience. And after being in software engineering, to the point at which I was just about to kind of transition into software architecture, I ended up switching over more to a neuroscience sort of view. I audited a 4-year neuroscience course, and so this is that kind of brought me to a perspective of noticing where things were going wrong in physics, because right at the point I made that transition, basically I'd gone from sort of a fundamentalist Christian religion to agnostic to short period of time as atheist, and then kind of realizing there seems like there's other things going on here that I don't understand, and it was sort of during my journey through neuroscience, because I had sort of found that all of my belief systems, the reason why I switched from agnostic to atheist, was kind of in noticing exactly how badly human beings tend to mess up knowledge systems. I started running into so much fundamentalism in science that sort of actually brought me to that point of atheism. I just saw it's like, wow, they're behaving so religiously, and by religious I mean the bad part of religion, because I do believe there's a good part of religion. It's just there is also a bad part, I believe, that when people behave in a way that is where they don't have faith in God, they have faith in themselves. They believe in their narrative or the narrative of their group or whatever it is so strongly that they're not willing to ask if them or the other humans are wrong about their religion. And so there's just that behavior is right there in science also. It's very religious behavior in the negative term, in the negative sense. So that's kind of where I was coming from when I transitioned into neuroscience, so I can understand why is it people are doing these things. Why is it they have these perspectives? Why do they have these changes in the way that they look at things? Why don't they change? How does all that work with all the different fields of psychology, anthropology, all of the different sciences that look at humans and try to explore, what is it that impels us? What is it? Where are our cognitive problems? Like one of my favorite examples of us just sort of making things up is that there are 2 points where light comes into your eyes, where it hits right at the optic nerve. So you actually have blind spots. You literally have places that in your vision at all times, like right around this area, are completely, your brain's making it up. You think that you see something there and you don't. There's nothing there in your vision, and there's neat little things that you can use to make your blind spot and make things disappear that you're looking at. And so it's just understanding this a fundamental cognitive error of humans is the perspective I came at to sort of re-examine. That's how I sort of left the physics interest area and went back into neuroscience, and then from there back to physics again with that perspective. So this was something that me and Deepak were talking about here that I still always find it funny. But basically you just have all these people in a circle, and there's the real versus the imaginary. What is your field, real or imaginary? And even the division is given that it's a cycle like this, the division is sort of people don't want to know how much they are based on this cycle. They want to believe that their science is real. The people who, at least the people in the imaginary area, have some indication and some understanding of the fact that they're dealing with very fuzzy topics, and that their idea of truth is not so hard and fast. And the people kind of at the top side of the line, well, they may not be aware of exactly how much their ideas are based on softer ideas. That you can't have deduction without first induction to supply you a base starting principle or axiom. And so there's this fundamental reliance upon something fuzzy that whenever you think that you're doing really hard rational logic sorts of things, you actually aren't, because it's based on something below that. And there isn't that. We want to believe there's this hard thing that we can grab a hold of, and it turns out that it's a little bit imaginary. It's useful, but it's not necessarily as real as we believe it to be. So then the crisis of origin is something I was wanting to kind of use as a topic. So you go and you want to believe, you want to find some origin to things. And when I started in religion, well, there was the origin, God made the universe. And when I switched over to the science religion, well, there was the Big Bang. And so there was some sort of origin, some sort of stopping point. And it's very convenient for a human mind, because we have this problem of infinite regress, where we can get caught in a loop, and that's called a memory leak in programming terms. So the name of this presentation here is Reverse Engineering Mysticism, and it's all about an engineer's perspective. And so if I'm going to take an engineer's perspective on the way that the brain works and the way the brain fails, and how it is that these failures are a pollutant to science. And then once we fix the pollutant to science, the funny thing is we end up coming up with mysticism again. But the way in which we do it, though, it doesn't feel like mysticism as much. It doesn't feel, I'm going to say right here, right now, for anybody who is a viewer that is very much on the hard science side of things, that I believe in determinism. It's not the same linear determinism that of yesteryear. It is chaotic determinism, which is much more holistic. It is much more simultaneous. There's much more of a kind of a, normally you think of this linear path of causality, and I don't think of causality in that way, because there are too many things to the side. You think of this linear path, this leads to this, leads to this, leads to this, but there's so many other things coming in from the sides that there is this lateral causality, is what I like to call it. So there is a perspective that I have that is very hard science, is very, I'm hoping to lead those of you who are watching from a very, 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 very hard perspective. I don't believe in magic. I believe that there is magical thinking in our current science that is a problem. And so the message that I tend to give seems to, if you're at either extreme, it's going to upset you. If you're at either the extreme of materialism or at the extreme of spirituality, and you think that you have your view down pat, you don't need to worry about it, don't need to think about it, then you're not going to like what I have to say, because I believe both ends of this spectrum are they can reach an extreme that is not workable and not useful. So my point is, I'm going to lead you through, and we're going to get to spirituality from just complete hard science, and not just hard science, but a deterministic, mechanistic, sounds like materialism sort of perspective. And so I hope you'll enjoy this as we continue going forward. So the way in which I'm going to do this is we can find that our problems in humanity kind of break down to a couple of causal factors, and our societal problems are related to science. So there is this behavior of people, and then there is science providing resources and materials, and that's our two major areas. And that's really science and religion, or science and philosophy at the very least. It's if you want to consider it more religion to be in more general terms, you can call it philosophy. But all the problems that humanity currently faces, all of them lie at the crossroads of mind, matter, and energy. So in understanding those things, how they work, where they interact, artificial general intelligence, all of these things end up coming back to these same perspectives and ideas. So Since spirituality is our most ancient exploration of mind and consciousness, and it plays such a crucial role in human behavior and in our interpersonal relations, our culture, we have to find some conciliation, some way of reconciling our spirituality with our physical sciences, and Deepak's been doing that for quite some time. From one direction, I'm wanting to do it from the opposite side, from a kind of a different. I want to, provide a different way of coming to the same conclusions. And like I said, there are people who, on the spirituality side, they're like, there's no way you're going to arrive at spirituality from a mechanistic, deterministic view. And then there's people on the hard science side. There's no way you're going to, have a hard science perspective with spirituality in it. And I'm going to have to tell both of you, just hold on. I think we can get there, even in this short little video. So the one of the observations that I think that everybody can kind of agree on, that is there is the observation that ignorance leads to suffering. Now, in Eastern religion, it's going to be ignorance of self. It's not understanding who and what you are that leads to suffering. It's you're lacking a wider perspective. But from a mechanistic, sort of viewpoint of, in a science-based perspective, not knowing what's going on and or who you are, or a number of things, does end up leading to suffering. So that's something we can kind of agree on. And I want to apply a software development life cycle and debugging perspective to our entire worldview. And that's what this whole project is about. And there's two different facets of it, of course, that I've mentioned. One is coming directly from just the science side, and the other is from the philosophy and spirituality side. Excuse me. So, I think I moved things. So to kind of address the whole problem, we need a language. That is sort of from a programming perspective, you need a language to address things. And as I said in the interview, Deepak uses science and engineering words for spiritual ideas, and I wanted to kind of complement him in my approach and use spiritual words to describe science and engineering concepts. And so I'm going to be doing that, and hopefully, instead of making nobody happy, it makes everybody happy. That's kind of the goal here. But I suppose if you're at one of the extremes, it could be one of the making nobody happy. But I think there's a lot of you here in the middle with me, and I hope you'll grant me some flexibility in language, because I think that the flexibility in language is going to allow us to reconcile these two different worldviews. So one of the things that I do, coming from the programming perspective, is I look at the necessity of abstraction and to avoid infinite regress. So like when I first got into programming, I had this thing where I would get stuck in infinite regress. And because when you're a programmer, you don't, or when you're a software engineer, either way, even when you're just doing straight programming and not as much software design, you have to rely on other people's programs, and those programs rely on other people's programs. And there's these layers and layers that go all the way down to the metal. And so I don't do anything that really directly addresses, I write no code that directly addresses the hardware. And that means that there's kind of a faith I have in the systems and how much they've been tested. And so there is a requirement of faith to be a software engineer. You have to be able to rely on other people's code. And so, the minutiae such as hardware address and the raw mathematics, that's all handled at a lower level. But a software engineer works with highly regimented abstractions. In other words, it's not just willy-nilly feels. There is a even though it's abstracted away from the ways in which those systems work together is like gears. You don't get a semicolon out of place without things going, pretty badly wrong. Sometimes the funny thing is you can make a mistake that ends up working. That's the worst kind. It's always best when the compiler can find it. But so understanding that you're using a highly constrained system to work with these fuzzier parts is part of higher order logic. So there is a higher order reasoning that kind of separates. So there's something we've been able to understand here in the recent years with regular AI, and not AGI, but AI and computers, is that an AI of like a chatterbot Excuse me. The AI of a chatterbot, and is a very simple one that can seem to be doing something that it's not. It doesn't understand what it's doing. It doesn't, and programs can do extremely complex mathematics. They can carry out the operations of mathematics. They can do things. They can memorize and regurgitate. They can bring up facts and figures. They can store vast amounts of information. They can do it perfectly every time, reliably, much better than a human. But we think of them as dumb. We think of them as not the type of intelligence that is human-like intelligence. In other words, there's something more important. There's a type of intelligence superior to mathematical intelligence. And that's kind of what I'm talking about here, is a higher order intelligence. How is it that we fit together parts to make something bigger? And how do we fit them together in a way that works? In other words, it's not just fuzzy woo. It is something that is a workable system. So software architecture design is kind of the perspective I'm going at here in looking at the way, at all of the different aspects of science and all the different analogies, because there's many ways to accomplish the same thing mathematically, even in physics. And of course, the same thing is true in programming. You can do the same thing with various different languages. So not just the different orders of operations and different sets of formulas and things like that. So software architecture design is something that is about taking these abstracted pieces and making sure they work together into like an engine. In other words, it's making sure that it's not designing the individual parts of an engine. It is putting them together and making sure that they are the right parts in the right places with the right timing in the right interfaces. And it is a very structured logic, but it is a higher order logic, and that the fact that exists is something that hasn't really been well understood until recent times, and it's part of the more human aspect that artificial general intelligence is needed to in any way replicate. So surprisingly, an electrical engineer may in fact not make a good programmer, because it's just a different kind of logic. There is one is more cyclical and more trying to make sure there's coordination. So it's more coordination dynamics that are at play. And one of the things you'll find is that programmers have a hard time making multi-threaded programs, which are, it is the multiple threads executing simultaneously. And that was actually when I started doing some server programming and had to deal with multi-threaded applications. There was kind of a perspective shift there, but the point is that there is a type of logic that's required that is slightly different for an electrical engineer who's down there at the soldering things together sort of level, and somebody who is more up at the systems design level. It's more top down, but again, it's not wooish. It's not unstructured. It's not any of those things. There is a structure to it. It's just more abstracted. But there are hard surfaces between these abstracted things that to make sure that it really works. So let's move on to the Neoclassical Revolution. So what is the Neoclassical Revolution? That is revolution within constraints, because here we are. If we want to have a revolution in science, as has been so frequently mentioned, then how are we going to have a revolution if everything's pretty much figured out? And so we have these two opposing views. We've got this idea, we have the God particle and we got it all figured out. It's all done. Nothing to worry about here, but we need revolution. Those things are completely in, they're in conflict with each other. And so how do you resolve that conflict? And that is what I'm hoping to do, is resolve the conflict. And that can be done through revolution within constraints, and that is a revolution of perspective. So one of the things I say here is it's like altering the angle of light through a complex crystal. So if I were to take a crystal, it's unchanging. It is, let's take it to be like mathematical truth, or at least what people think of as mathematical truth. It is a mathematical structure, but if I shine light through that crystal from one angle, I'm going to get the light bending and changing and coming out the other side with one picture. And then if I change the angle, I'm going to get a different picture coming out, but it's the same crystal. It's just a different angle on it. So philosophy, theory and interpretation are exactly like that when it comes to the mathematics of physics. That we have a light we're shining through the crystal, and we think right now that there's mainly only one way to do that with general relativity. That's not actually true, which I'll discuss in a moment. And there's only a couple of different things that are viable in quantum mechanics and quantum physics in general. And that there's only a couple of different ways we can shine the light. There's a couple of angles, but that's also not necessarily true. So the question is, if I want to reinterpret physics and revolutionize it, then I really need to look at the underlying structure. I need to break it down to be able to build it back up. That's how you redesign software. You have to break it down to its components, look at what the components are doing, see if they can be replaced in some way, see if they can be streamlined in some way, see if there was some decision you made early on in the design process that you've been married to ever since. That happens when you're designing software, and it happens when you're designing a worldview, which that's what it is our science is a synthetic worldview. We have designed it, and so therefore the human element is baked in, just like in a software program. You have these ideas of what you're going to do with your code, but the problem is it can go sideways. It can go what you end up doing later on can be completely different from what you intended. Because as you add and add and add, it just changes, and that ends up requiring a rewrite. And that's what I'm doing here, is asking people to do a rewrite of physics, but using mainly the same components and coming to the same conclusions, because they're all good solutions. So we need a way to come to the exact same mathematical conclusions, but somehow fundamentally change the way that we're looking at it. That's a revolution, and that's what the neoclassical revolution is. So for 15 years, I've been trying to make people understand one thing from a variety of angles, just so many different ways. And I've had to, the primary issue is specifically is isotropic constancy is not empirical science. Anisotropic versus isotropic constancy are two different concepts. And this is the most recent terminology. I've used a lot of other terminologies to represent this, but it was something that, like I said to Deepak, I was very happy about the recent video by Veritasium, where they finally addressed this issue. And I spread it amongst our group, and I hope that lots of people are talking about it, because it is a crucial issue. And that is, that we've identified that space-time is not empirical science. The conjoining of space-time is a representation of isotropic constancy. That means light is constant in one direction. Anisotropic constancy is that when we calculate both directions, up and back, then it seems constant. But you can have an illusion there. And that illusion is the difference between Lorentz-Poincaré ether and Einstein and Minkowski relativity as we understand it today. But they are mathematically equivalent, yet there is an axis on which our entire worldview can completely shift. And that is, we can bring back the ether, but it has to fit certain things, of course. But the point is that the ether was there and developed very, very intricately. It was the basis of science. And it led to all of the advanced mathematics that we use in physics today. People were working on these problems. So, this is a great quote I have here, talking about how we accomplish revolution within constraints. And I cherish more than anything else the analogies, my most trustworthy masters. They know all the secrets of nature, and they ought to be least neglected in geometry, by Kepler. So then if we return the ether, then basically what we have is hydrodynamics. So going back to Maxwell, who treated the ether as a inviscid fluid, and he looked at the way in which things worked, and he said that looks like, wheels and pulleys and fluids is how the electromagnetic medium works. From there was a lot of development done, and this is in my history paper, on knot theory and topology, and as Kelvin was attempting to create a version of atoms that I believe he got from Helmholtz, and he was trying to come up with something that would work with all of the other established physics of the time. And he eventually did. He came to a finalization and a conclusion in 1889, which is only 2 years after the Michelson-Morley experiment, 1887. So by 1889, everybody was already dealing with this major problem with ether that in their conceptions. But Kelvin had actually solved some of the major problems of ether, and it just didn't get a whole lot of discussion going. People were dealing instead with the Michelson-Morley experiment. But that's a longer discussion I'll leave for a different talk. And what we're going to talk about more here, what I've got displayed on the screen, is something that's called either the Walker experiments or the Coudet experiments. But the primary researcher in the field today that's kind of carried on Yves Coudet, his work, is John Bush at MIT. And there's definitely other researchers. I don't want to minimize them. They're just not, I just haven't interacted with them very much. But what you can see there is that when we cause a fluid to be vibrated, what can happen is a little droplet can bounce on the surface indefinitely. And then as it moves around, as you can see up in the top right-hand corner there, it will move in what appears to be a random fashion. But eventually that randomness comes about to be the Faraday wave mode of the cavity, which is exactly what we see when we use an atom trap. And you can see in the bottom right-hand corner there. And we see that exact same pattern of what we believed was random occur. So here's a way in which the randomness at the quantum level may just be happening too fast for us to see. Maybe just something occurring that is so fast and so complex that all we see is the outcome over time. And the outcome over time of these droplets is the same as what we see in quantum mechanics. And there's a variety of other things that basically every single quantum mechanical behavior that we have observed can be represented with these walkers that walk upon the surface. And it's something that is very amazing that once again, I've been talking about for years now, that people don't seem to want to spend too much time thinking about, because now our idea of randomness is also completely and utterly unnecessary. We've got a system that the biggest problem that, Feynman talked about, that's like the crux of quantum mechanics is the dual slit experiment. And here we have a system by which we can replicate the dual slit experiment in a completely rational way. And it was something Feynman said, it makes absolutely no sense. It didn't make any sense when he said it. But now we've got experiments that can show exactly how it could really work, and we no longer have to accept it as just some vague idea. So in addition to that, going back to the Kelvin model of atoms, there are a variety of things going on. So one of the things I wanted to bring out is that the work on the neoclassical physics perspective has been going on for a long period of time. Like I mentioned in the talk with Deepak, there is Einstein said, space without ether is unthinkable in 1920. And ever since then, so basically he considered general relativity to be an ether theory. And so what you'll find is that there are a wide array of people who've been working with general relativity, and even now in quantum mechanics, where they understand that the vacuum is something, and it has properties, and it has behaviors, and understanding how those properties and behaviors work ends up giving us a perspective that the only reason why we have big problems with it is we keep believing in isotropic constancy. We keep believing in space-time conjoinment, and that confuses everything. So when we drop that and we just go back to, okay, well, there is this neat mathematical illusion that makes things look constant. I won't describe that here because I've described it elsewhere in a variety of places. And there's There's a way to understand it very, very simply, that it's a mathematical illusion. It isn't like an optical illusion, just like an illusionist on stage does. Constancy can be described in that way, and it makes perfect rational mechanical sense and has none of the paradoxes that you typically see with relativity. None of that even starts to appear. Every bit of it makes sense, and whenever you look at the solutions to the paradoxes that people present for special relativity, they're actually reducing our faulty conception of special relativity that Einstein did not actually prefer, because he talked to that constant. He said that constancy is not applicable, and it's reducing it to the Lorentz-Poincaré ether, this relativistic ether. That's what they do each time in those. Whenever they try to explain it, they give it a preferred frame. But they just haven't been aware that there's an illusion version where that has to do with isotropic constancy versus anisotropic constancy, the two-way speed of light versus the one-way speed of light. And like I said, this is something I was so glad to see it was on Veritasium, because 15 years of talking with people about this, and I haven't been able to make. I haven't been able to make the impact that I wanted until, I suppose, now. I mean, I've got thousands of articles on it that people, I suppose, have been reading for years now. But so let's look at spin, for instance. So the concept of spin, whenever you try to drill down on it, there's a variety of concepts in physics that are problematic to an extent, in that they avoid the infinite regress by just stopping somewhere and saying it just is. So there's kind of a bottom turtle. We always have to sort of give a bottom turtle, otherwise it's turtles all the way down. This is just a funny little thing a lot of people in the philosophy of science tend to talk about. And so we present that this is the bottom turtle, but it really isn't. And spin tends to be one of those things, because the only really good explanation of spin is probably that bottom left-hand corner idea of a spinner. And that actually, it performs the belt trick in that it for one time around, and it twists the belt. The second time around, it untwists it. It's really fantastic. I recommend you look at the other image from on the spinner Wikipedia webpage. And so that's a good idea of a spinner. And so once we sort of take that perspective, we can start to look at Kelvin's knot theory of atoms, and through some of the newer developments like skyrmions, and and then the older things that we've understood for quite some time, like solitons and topological defects. All of these things are just ways of looking at fluids. I mean, it really is just, when you look at a fluid, you can create, like what we have right there in the middle bottom is an experiment where they are creating knot vortices. In other words, there is they've got this little plastic thing that they've 3D printed, and they pull that through the water, and it leaves behind these bubble rings that are very much like the structures that we have used, first off, that Kelvin and others used to understand how an atom might work, or at least a particle might work, because of course there's a difficulty in understanding, at what level that we're talking about here. Is an electron just a soliton, and then within that there's a soliton, traversing that line of a vortex? There are questions like that of course are part of the exploration that we could eventually get to, if we could accept a different worldview and so we could start to ask questions, because that's what this is about. Another interpretation is about asking questions. It's not about saying this is reality, this is absolutely the perfect and true truth. It's just that there's another perspective we can look at things from, and it's interesting all the things that this perspective could lead to. So there's also string theory, and understanding how string theory applies here is that the string theory is not exactly the same. You could rework some of string theory to work because it kind of descends from knot theory, and kind of this parts of it. In the mathematical sense, there are things that descend. Most everything descends from Kelvin's work on the ring vortex model of atoms. And so you'll find that string theory has some of those ideas. Now, they went in a different direction, and they're looking at it from a very different perspective, but there are ways in which we can bring that back in to a fluid dynamical sort of perspective of the way things work together, kind of like gears. And as you can see, I've got the tri-gear as an interesting little thing that I've put over there on the right-hand side. So I promised that this would eventually lead to spirituality, and I've been talking about physics. That is where computation and data come in. So most any materialist, atheist sort of perspective, you can believe that you, whatever you are, is a collection of data, and it's a specific interrelation of data. It is a certain way in which data comes together that makes you. You're not a single note, you are a symphony. And that's what makes you different, is you are your own symphony of information. And but this is kind of the gateway to the ephemeral, to the spiritual, to the things that are not solid. In other words, we tend to, now a materialist wants to say to themselves, well, information always has to, be on material, so therefore it's just material. That's not really necessarily true, because you can disconnect information from the material in a certain way. So it has an independent reality, is what I want to say here. And it's the fact that the same information can be stored on gears, it can be stored on beads, knots, magnetic fields. It can be stored in a wide variety of ways. So information doesn't care what it's stored on, and what it's stored on doesn't have to be necessarily perfectly physical. In other words, there can be fields store information. So if fields can store information, and then we see that here, what I've got over there on the right-hand side is Babbage's difference engine, where that's just calculations occurring by winding gears. You can crank that thing, and gears, and the spaces between them just move about, and that ends up doing some complex calculations. So the thing is that from a material physics standpoint, an assembled engine is, it's got the same weight, it's got the same number of atoms, it's got the same, everything about it is the same, other than the way that it's arranged in space. So from a material standpoint, an assembled engine and all the parts of it taken apart are exactly the same. What's the difference between the two? Information. And I'm saying that this is the differentiation we need to look at. This is the ephemeral that is disconnected from the material. The material is still there, but when we rearrange it, that's what information is. So it's something that is above material. It's not, material helps define it, just like a riverbed, helps define where the water is, but the water is what cut the riverbed in the first place. So there's there's always a confusion there, and there's always a want to say that this is what's primary and this is what's secondary. But when you've got two things combining, your idea of primary and secondary are sometimes just wrong. And this is where Hofstadter's book, Gödel, Escher, and Bach is useful in seeing how we have these infinite loops we break ourselves into, where we should be breaking out of, but we get stuck into that, where you keep asking what came first, the chicken or the egg, and you keep coming to some answer that's definitely the egg. And so when people say it's definitely the material, that's what they're doing. So the point here is that there is a more energetic, in other words, there is more potential to impact the world in an assembled engine than there is in an engine that's in parts. So that is an energetic, a potential energy way of talking about information as a potential energy. So there's the quote from Maxwell down at the bottom. So now there is only really one way in which talking about the vacuum will work, and that is as a superfluid, or even a super solid is another less used term. People are more familiar with superfluid. And most of the experiments have been in superfluids, but I believe that we may end up calling it a super solid. But superfluids and plasmas have self-organizing behaviors. One of the things that, like down there in on the bottom left, what I've got is a slice through of vortices. So whenever you spin up these plasmas that then create this very chaotic mix of vortices, they end up arranging themselves into crystalline structures. In other words, the arrangement of the vortices around each other ends up being like 5 or 4 or these exact, polygons. I probably should have picked a little better one. There's better pictures, but if you look up plasma vortex crystals, you'll find that this is a fairly common thing. So there's a self-organization that happens. Well, one of the other things that happens in a superfluid is that it automatically creates these vortices that are these long strings, kind of like we're talking about, almost like we might be talking about string theory, or if we might be talking about Faraday's lines of force, which is what some of Maxwell's first papers were called, is on Faraday's lines of force. So in a superfluid, you have these vortices, and you end up with lots of vortex filaments that happen as this superfluid contains energy, and so the energy is in the rotations, and it's in and those rotations organize themselves into strings, and those strings can sometimes organize as well. So what I've got down there in the bottom right is just, it's showing you how these strings can be very chaotic, but they can also start to agglomerate in ways that should look familiar to both neurons and patterns of dark matter in the universe, etc., things like that. So that should be a very familiar look there. But this is down at very, very small scales in the ether. In other words, what I'm proposing here is that down at we're talking about things that get very close to the Planck scale. Whenever you're talking about these little strings, this web of superfluid filaments. So now, with this idea of an ether, so we have an ether that is a relativistic ether, and you've got general relativity actually kind of expresses these things like spin and things like that to the ether as when you talk about a general relativity type of ether. Then we also have this neat, Walker thing I talked about, where the walkers walk on the surface and they end up having these quantum mechanical behaviors. Then how do we marry these things? How do we marry all of this into a single unified perspective? And like I said, I promise we're going to get to how this has anything to do with spirituality. So how do we marry them? Well, first off, we have to have some way in which a walker has a restoring force. What is it, since walkers have gravity to make them bounce over and over, what is it that's causing that up and then down of a droplet? And what exactly is a droplet in the analogy of the ether? Well, instead of it being a particle, which is kind of, in the past, we thought of the electron as a point particle, then we thought of it as a sphere. We've got all these different, views of them. Instead of it being a particle, it's my hypothesis that instead it is a cavitation. And you see down in the bottom left-hand corner there, I've got what you can see is how a space can open up in a fluid and then close back down because there's no gas in there. In other words, it's just a space of vacuum, a space of nothing. And so in the case of ether, I'm saying that there may be these spaces opened up in the ether that are torn open, and furthermore, that's exactly what a black hole is once it's so what I'm saying is that massive particles end up tearing open the ether. And then if you've got a tremendous amount of mass, then it's going to tear open into a black hole. And that tearing open of a black hole basically makes it a 2D surface. So that's going to be important for other discussions. But the point here is that the droplets that organize themselves, as you can see here now, that you've got those shapes, those crystalline shapes coming up on the self-assembling bouncing droplets. And then I've told you about how plasmas will organize themselves into these crystalline structures. So looking at it from this perspective, so now we have a way in which these walkers can have their randomness. How they can have sort of a discrete existence. And I'm not saying that they're always necessarily popping in and out of existence as it rips open and closes up, but there may be certain circumstances that as a wave crosses a vortex or something of that matter. So this is kind of the way in which you can understand how this whole system works, where, as I mentioned in Deepak's interview, that that we're looking at the world inside out. And so now we're going to go over to information. So that's where black holes and ether theory can actually start to make sense with each other. So ADS-CFT is anti de Sitter space conformal field theory, and that is holographic theory. So in other words, whenever somebody talks about the holographic theory of the universe, they're talking about this, and that is that there is this correspondence between the no gravity particle theory, the conformal field theory, and the excuse me. They're talking about this relationship between how this outside of the sphere basically can represent the string theory that is inside of it. So there's this correspondence. This relates to that, and they're basically two different versions of the same thing. In other words, the surface somehow holographically projects the strings inside it here. So that is what holographic theory is about this 2D surface. And then when waves bounce against it and they come back together and converge, what you end up having are these particles. So in other words, that's how these two different parts of our theories from gravity, theories about gravity, and our particle theories, which we've suggested maybe there's a graviton, but we haven't been able to take care of the whole idea of gravity in particle physics. So these two different ways of looking at things, looked at from this third perspective of a neoclassical ether sort of perspective, with vortices impinging on this surface and being part of it, you have a way of looking at a holographic theory in a completely novel way. And so why does this have anything to do with information? Well, it is a question of how does computation itself work? And I believe that one of the things that we'll end up finding as we continue, and I don't want to go too much further down this path, because there's a lot of good work being done on how information and black holes interact, and this is part of information theory and thermodynamics. And the way that I am proposing that there is a computational process is that in fluid dynamics, vortices in 3 dimensions are different than 2-dimensional vortices. So the strings, when you cut them at both ends, that's thought of as a two-dimensional vortex. But a vortex in 3 dimensions is generally like a torus. So you've got there's the center of it may be a little tornado-like part, but then there is the outside part that is like a donut. And so the three-dimensional vortices and 2-dimensional vortices have some differences, and that is whenever you're dealing with fluid dynamics, we generally see things break off into smaller and smaller and smaller and smaller pieces. That's how the vortexes work in most fluid situations. However, whenever we look at 2-dimensional vortices in plasma, they tend to be able to join with each other. There's these dynamics that we find that as a vortex hits a 2D surface, there is something that's kind of like a computational event. And I believe that is the way in which computation is occurring in the universe, is that at these borderlines, at the edge of the universe, which is in the black holes, and then also our particles themselves are these twisted up parts of black hole, I suppose would be one way to say it. In other words, all matter is basically the same as a black hole. A black hole is just a really big bunch of matter, right? And that there are these 2D surfaces that allow computation. In other words, so if you think of computation like in the slide I showed you before, with the gears going against each other, one of the ways that you need for that computation to work with those gears that won't go unless they're separated. And so this separation allows the gears to slide. And so that can be like a computational event. And so there's a lot of work that's being done there. And this is where I want them to use this model to understand, to look at the same theories that they are developing. That this, like I said, this is something happening. The neoclassical interpretation is the collection of a lot of people looking at things from thermodynamic perspectives. There's even something now called quantum steampunk, where they're looking at thermodynamics and information theory, and they're trying to understand this borderline of, how does entropy work and how does that have to do with black holes and information. So that is a field that is actively being pursued. It's just there's been this one blockage, and that is not allowing there to be an ether, even though somehow all these people all kind of understand there's this substance, but it's not substance, is what they want to say to themselves. And they don't want to say ether, or they haven't for the past, roughly 15 years ago. They certainly wouldn't allow you to. But now, as I pointed out with Frank Wilczek, there are people who, so long as a Nobel laureate can say ether. Now we're beginning to be able to say ether again, but you have to really, you got to say it in a stodgy way. That's like, well, it's not the old ether. You got to make sure to say that. And I don't believe that that's a necessity. I think that we can say, yes, it is the old ether, but we have to add some constraints to it, add some changes. So what does all this mean? So I've been talking about waves and vortices and, and information and, what am I even talking about here? So what I'm trying to say is that the universe is constantly being created. And that is, its convergence leads to emergence. And so as you see in the little picture up there in the top right-hand corner, what they've done there is that's just a sheet of plastic with black lines on it. And then there is a special drawing of lines that once they interfere with each other, when one set of waves interferes with another set of waves, they cross each other. Sometimes things are added and sometimes things are taken away. And so what can happen is you can have a parent phenomenon. That gear emerges from the combination of what is basically two wave patterns going through each other. So waves also underneath the surface create vortices. There's something called wave vortex duality. And so whenever you there's a point at which you can have a standing bunch of waves on that you're doing an experiment with that create like a checkerboard, and eventually that checkerboard, the vortices that are underneath there that accommodate the waves end up being a checkerboard of vortices right underneath the waves. And so there's this wave vortex duality, because as waves try to go through each other, if you think of it from that perspective of gears, then they have to be able to, what allows a wave to go through another wave, them to just, if it's a wave to a peak to trough, they look like they destroy each other and it flattens out. Well, then how does the wave come back? You have to ask yourself that question. A lot of times people, when they're thinking about waves and things like that, they don't really think this through. How it comes back is rotations. There are rotations of the substance that the wave is going through. And then those rotations lead to the wave being able to continue. And those rotations are basically how vortices end up forming in these fluids. But the wave and the vortex are basically the same phenomenon. It's just a squeezing and stretching and rotating of a substance. So vortices can alter waves. Waves can create vortices. And there's these interactions that happen between them. And so the stresses of the motions can tangle a substance, especially if it's a very locked together substance, like a super solid would be, and it can tear tiny holes in it. That's the cavitation that we talked about earlier. So what I'm saying is that this is a view of particles that you can understand, just like that heart shape down in the bottom right-hand corner. There's a wave pool that people have designed in Japan, that is, where they can make any shape appear. But as you can see, the waves, as they're going through, they look like a mess until they get to a certain point at which they converge. And at that convergence, a heart shape appears. So convergence leads to emergence. So therefore, our ideas of a particle traveling from one place to another may be wrong in the idea of locality. Locality can simply be shared because a particle's existence is emerging. And so even when we look at the Walker systems where the droplet is bouncing, that droplet requires the waves coming to it. It requires the energy coming to it for its existence. Otherwise, it would just rejoin the fluid. It's the same fluid, but it's the energy converging at that point, plus the energy contained within it, that give the walker its existence. So it is an emergent existence that's being created over and over and over. And that is what I'm insisting is occurring to matter. That's what matter is. It is a convergence that leads to the emergence of what we think of as physical reality. But again, our view is inside out. So holographic universe, holographic mind. That is the idea of the holographic universe. A lot of times people think of, help me, Obi-Wan Kenobi, you're my only hope. And they think of the little projection and things like that. I don't want you to think of that. I want you to think of like the waves in that heart, where waves are coming together and then something happens at that point where it tears a hole that you can recognize, but it's just a temporary structure. And what's really happening is what's all around it. And the same kind of thing has started to happen with neuroscience, where at first we looked at just the connections from one to the next, to the next, to the next of the neurons. But now what we're understanding is that there are coordination dynamics. There's coordination of brain areas where waves travel through, where the firing over here and the firing over here are somehow coordinated. And they happen at exactly the same time. So you have these waves traveling through the brain. Well, that coordination, the only way that could really happen is somehow through fields. And so one of the things that happens is as electricity passes through a wire, well, you create a magnetic field. And the thing is, if you take a magnetic field, run it along a wire, you'll cause electricity to go through it. So of course, if you look at neurons in the same fashion, then doesn't it make sense that the firing of one set of neurons would do something to the possibility or probability of the firing of other neurons? Seems fairly simple, but it's been something that has been hard to prove, even though, and there's really kind of been an orthodoxy that has not so much rejected it as much as just avoided it up until recent times. But there's been so much in the way of coordination and looking at fields that people are beginning to understand that there may be something called like stochastic resonance, where very, very, very fine and small signals can be picked up, and this could be altering the probability of firing patterns in the brain. So what I'm saying here is that these waves converging in the brain to create pathways that are what determine your thoughts. So it's the waves and how they reflect. And so I've got the picture there, of course, of the holographic idea of the brain, and of course of space. That's actually a picture of space there that's sort of pulled out. So, and then in addition to that, for those who are more along the hard science, and they'll be like, well, neural networks work just from, in the connection thing, the synaptic connections is what we originally tried to model with neural networks. Well, that's a fuzzy way of saying it, because, and this is my argument, that there were definitely changes we had to make to fit it into the computer architecture. And so when people say things like that, they're actually kind of stretching the truth a bit. But there is a sort of a truth to what they're saying, and I understand what they're getting at. And that is, but what I want to stress here is that people don't understand how neural networks work very well. We got it to work, and then we didn't understand it very well. And this is, there was a talk by Max Tegmark fairly recently that I really enjoyed, where he was saying, we don't understand neural networks, and we can't just run forward without understanding them properly, because who knows what might come out of it. And so there's this lack of understanding that, once again, I believe this perspective on the universe will allow us to understand neural networks better, because once we start to, one of the things that people have been designing, to come at it from a different angle, is holographic neural networks. And what I'm saying here is that the information stored in a neural network is a hologram. So what is a hologram? I guess I need to cover that really quickly. And that is, a hologram is the way that waves converge. Okay, what I mean by this is that when you get down to the surface of like any picture that you print out on a regular printer, you're going to see little dots, and those dots, and as you get closer and closer, you're just going to see dots that are one little part of a picture. That's not true of a true holographic surface. Now, I'm not talking about the ones that you can scratch in and they make the little zzz sound, not that. I mean, there are true holograms, and those holograms You say you have a hologram of a star, you can cut it in half and you'll have 2 holograms of a whole star. And how is that accomplished? Because it is about convergence. The image of the star exists at the convergent point of your eye. So when you zoom in on a holographic plate, you see these weird lines that are, well, I'll tell you what they look like. They look a lot like that, those lines in the gear there. They look a little bit like it anyway. And there are these, they are basically interference patterns at the surface. And so it's not like a typical image. Instead, it's this surface. And what does that surface do? It allows light to come at it from various angles. And then when it comes up, the different parts of the hologram, the light coming from here and the light coming from here on the hologram interferes with it. And then so that's why the whole image has to exist on every part of the hologram, so that when it gets here, which is actually, I should be putting my fingers in my eye, but I'm not going to do that. When it gets to your eye, that is where the image is created through the interference. The fact that waves, that peaks destroy troughs and create something else. So it is a convergent event. That's how a hologram allows you to see all the different angles. That's what's happening. So what I'm saying is that's what's happening in the brain, is that there are these patterns of waves that converge and allow these structures to fire in certain ways. And then those structures represent parts of reality. Now, there's a whole discussion there. I won't get into how representation, et cetera, works, but that's part of my work and some of the things I've been talking with, neuroscientists and linguistics and all the great people who are in the group with me and Deepak, and in trying to come about what tools can we use to assemble a new view of reality that makes sense with everything we already know, but gives us a completely different, revolutionary viewpoint. And so that's where, here, if you saw the video, or my interview with him, the thing I like to point out here is, you look at this picture in the bottom right hand corner and you see a fish swimming upstream repeatedly, and you think it is the fish swimming, but it is a dead fish. That fish is not swimming. The fluid around it is moving the fish because of the structure and shape in the fish. There is a structure and shape to the fish that is important. It is part of the whole process. It's all one thing that's occurring. But what's more important is the action of the fluid, because that fish is not swimming. Looks like it's swimming. It's not. And so understanding that whenever we look at matter, what we're looking at is the tensions and the rotations and the reflections and the ways in which all of the ether around it is influencing it, is what's crucial, and that's what's critical. And so what I wanted to show here is this is a piece of string. Hopefully you can see it. You might not be able to, but we'll see if I can put it up closer to the camera here in just a moment. So what I'm doing is I'm twisting the string. And why am I doing this? Because I want to represent to you something that's a little bit like topological defects, but not quite. But the idea is the existence of a knot. And can we see that? Yes, there we go. You see how the knot doesn't exist when I pull it tight and then suddenly springs into existence when I just sort of, wait a minute, where is it? Oh, it moved. And that's important. You see how it moved? It moved from one place to the other. Did it teleport? Well, the point is the knot doesn't really exist. It's a phenomenon. It's what the string is doing. And you can cause this particle to apparently teleport by simply changing the medium that it's in. And so understanding this view, where we look at the world from instead of from this perspective where we see the shape and then everything outside of it doesn't matter. Instead, we need to have this perspective of everything outside is what matters and creates the shape. And having this completely different view of matter as a phenomenon, as a process, and as a constant emergent creation could give us a completely different way of viewing science and spirituality. And once we start to understand the way in which information is stored and processed in neural networks, which we do not yet currently understand, but I'm saying we will understand when we properly apply Pribram's model, which he didn't completely have it correct yet because he didn't have the same advantages of all of our different new technologies, for instance. When we apply it in a way that we see this analog computation along with the more digital computation. So the analog computation is the waves coming in and altering the probability of action potential. Then that leads to more a higher probability of it firing. And so this influence from outside and from the coordination that occurs, these waves interacting with the linear and the analog working together, is the revolution that that when we look closely, for instance, at Google's most recent quantum supremacy, talking about quantum computing, the quantum supremacy release was about a chip that uses a hybridization of analog and digital methodologies. And what's quantum about it is really more at the small scale and managing waves and understanding and using quantum mechanics. But there's something I want to point out here. So we use analogies. We use analogies like there's something called a phonon. A phonon is not a particle that exists independently of its substance. It's something that everyone who uses phonons understands it to be just like this little knot that I had in the string, and that is that it's only a phenomenon in the substance. It doesn't have an independent existence without the substance, and so there is good reason to believe that photons and other particles may be the same, that they do not have an existence, and furthermore that, of course, then that leads to matter. But matter, it was going to have to be more knot-like and less soliton-like. So talking about a lot of different things here, AGI, artificial intelligence, convergence of waves, and the emergence of something from it. And then there's, of course, the reflection of, reflection from a surface leading to these interference patterns. And basically that is a way of understanding how the human mind works through the holographic model, and then seeing that analogy happening all the way down at the atomic level, and then all the way up at the universe level, where our black hole is driving and pumping the black hole at the center of our galaxy is driving and pumping the waves that are converging from other black holes, from other places, and creating the matter that is circling around that black hole. And so our ideas of, for instance, of dark matter, whenever we looked at dark matter, where did the idea of dark matter come from? It came from the concept that whenever we looked out to the stars and examined it against our best guess of how gravity works, we were wrong. And it was, what did we look for? We looked for the rotation rates of galaxies, and the rotation rates of galaxies were off. And that's then we said, well, something's going on. Something has to be happening. So we come up with the idea of dark matter. Now, dark matter is not just non-luminescent matter. That's not what they're talking about. It is something that is basically an abstraction. It's basically pixie dust is what people have called it in the past. A lot of scientists out there have had a huge problem with it and called it pixie dust. And there's struggles between scientists on that get quite angry about this sort of thing. But the point here is that it was a fudge factor that we needed to make general relativity work again, and we just went forward from there, hoping we'd eventually resolve it. Same thing is true in quantum mechanics. We had fudge factors. There's specifically Schrodinger has a quote where he talks about how it's a it's a I forget exactly the words he used, but he was saying it was a crisis that caused us to just use these, desperate attempts. And he hoped that in some future time we'd solve all those things. And then later, Schrodinger also said, because of the Copenhagen interpretation, et cetera, that he was sorry he had anything to do with it. So, even our fathers of quantum mechanics didn't like where we arrived, and then we kind of tried to develop from there and be satisfied. But eventually we have to stop being satisfied and break through with a revolution. And this revolution, as I said, will be in viewing the universe through this fluid dynamics, through this hydrodynamic viewpoint, because it is available, it is there, and we can look at, we've already got all of these structures, these mathematical structures that work this way, but there's just additional things available. And so what I was talking about with dark matter is that once you start to see that the stars are not the thing, but the flow of the ether, that in general relativity, they call it frame dragging, when a black hole actually stretches space around it and moves it like a fluid, unsurprisingly. They call it lens thirring or frame dragging. And so we actually see at the macro scale, at the micro scale, we see all these fluid effects. We see that there is an ether. It's just we haven't been able to admit it ever since Minkowski died. And it's because we're not willing to get rid of space-time conjoinment, which again is based upon an idea that is not empirical. It is not empirical science. We have not ever made a experiment that says that this space-time is superior to this mathematically equivalent Lorentz-Poincaré relativistic ether. They're equal to each other, and we just decided on one over the other with no experiment. And that is what has led us to not have these other ideas and only partially talk about them and not really join all of these various scientists. And so what I've been working on is trying to join all those scientists together who are working on it a little bit at a time. And also, I think that I can get the help of the people in the consciousness community, because when they see that there is this other view that can work completely within our science, but it also supports a view of spirituality that is ancient, it's exciting. It's exciting to me. And so this is one of my favorite quotes from Nikola Tesla down here at the bottom. Long ago, man recognized that all perceptible matter comes from a primary substance or tenuity beyond conception, filling all space, the akasha or luminiferous ether, which is acted upon by the life-giving prana or creative force, calling into existence in never-ending cycles all things and phenomena. The primary substance, thrown into infinitesimal worlds of prodigious velocity, becomes gross matter. The force subsiding, the motion ceases, and matter disappears, reverting to the primary substance. This is by Nikola Tesla, because he was a great fan of Swami Vivekananda and was learning from him over a large portion of the time that he was developing his theories for electricity and things of that nature. And of course, the whole idea of the rotating magnetic field of how electricity should be pumped is an idea of pumping the ether in and through material, and so that's how he came up with ideas of resonance, because he thought of it in a fluid mechanical sense. That's how he invented. So it's interesting that here, when we talk about holographic universe, that there's also things like Indra's net, where there is the representation of the beads that reflect all of the others. So there's a description of a fractal here in these ancient texts. And the funny thing is, whenever we talk about ADS-CFT, anti-de Sitter space is a fractal. It has inside it a fractal. And the thing is, what I'm suggesting is that we turn that we have both an anti-de Sitter space and a de Sitter space. In other words, that we look at it from both the internal and the other way around, a way of looking at it, because what we have are these 2D surfaces that are wound up. These 2D surfaces wound up end up allowing these reflections from them, just like a black hole reflecting in on itself. Instead, we're shot through with all of these little threads all around us that are doing this reflection that's creating a fractal. And so that's where we have this particles being, I take ADS-CFT to be, that's why we can use our particle theories for particles, is because they are basically the inside of a black hole. That is what the cavitation is that 2D surface, which allows computation to occur because it allows the gears to move, and it does that through these vortex filaments. So here we have all these intuitions, and from here, I know if all of you have come with me this far, and you're really into the more spiritual side of things, then you'll recognize these ideas of an energy body. You'll recognize this interplay of energy and information, and as something that you've believed all along. And that's where I'm trying to get to, is basically describing this worldview from the assemblage of parts that will work into this one engine. So we have all these parts of physics, all these parts of science that through interdisciplinary work, there's an architecture in which all of them work together at their interfaces. All of them do their jobs, and there is an engine that is created from that, and it's greater than the sum of its parts. A pile of parts does not an engine make. And so what I'm saying is that by rearranging our parts through this viewpoint, which comes from rejecting the non-empirical science, returning to a deterministic universe, we end up solving problems of science and spirituality simultaneously and allowing them to talk to one another again and to integrate with each other. So the message here is that our view is inside out. The world is inside out from how we've conceived it. And this is what I call the neoclassical revolution. It's not just the physics. Of course, I've been writing on just the physics part of it in my in some of my publications. Probably the very best publication when it comes to just very simple and straightforward is my history, because the other two publications I tried to really bring together understandings of neuroscience and how the brain works and holography in my first publication. And in my third publication, I talk about a lot of the things that we're talking about here. And so so some of those things are, unless you have this presentation to tie it all together, it's kind of difficult to go through. But and as you can see here, that's space without ether is unthinkable is one of my favorite Albert Einstein quotes, and also I already read these quotes at the end of the interview with Deepak, but I wanted to continue on the finest emotion here. The finest emotion of which we are capable is the mystic emotion. Herein lies the germ of all art and all true science. Anyone to whom this feeling is alien, who is no longer capable of wonderment and lives in a state of fear, is a dead man. To know that what is impenetrable for us really exists and manifests itself as the highest wisdom and the most radiant beauty, whose gross forms alone are intelligible to our poor faculties. This knowledge, this feeling, that is the core of the true religious sentiment. In this sense, and in this sense alone, I rank myself among the profoundly religious men. So there is and I feel the same way. I agree with what he's saying here, and that is that there is a part of creativity and exploration that actually, when it comes down to the design of AGI, we're going to have mistakes be part of how it works, because mistakes are what creativity is. Now there's the best way to look at this, for those of you who may actually be familiar with artificial intelligence, there's something called an adversarial neural network, where there's basically these two pathways of doing things, and each one of them sort of refines the other and adds to the other. And there is a growth and pruning phase to doing things. So there is actually, one of the things that we'll find is that in the act of creation, mistake is part of what allows creation to occur. Now, it's mistakes within borders. It's mistakes because they're not really mistakes. They're an outcome of the trajectory of how everything has been happening before. So they are constrained. There are constraints, and there's an area, but it's an area of exploration. And so we'll find that creativity, as we're designing AI, is going to necessitate mistake. And so kind of having this these creative leaps in which we get things a little wrong here, a little wrong there. I think that that's going to be crucial in understanding and advancing science as a whole, as we bring forward AGI and physics and all of the different sciences are begin coordinating more and thinking together as one entity. And as we basically raise humanity to this level of becoming a singular organism that can take care of itself instead of, constantly attempting to, like an organism with an overactive immune system trying to kill itself. And I believe that the masters of the great past and the masters of the recent past have all been speaking with one voice, and there's just been little mistakes made along the way, and we've got here because we're supposed to be here. So I hope you'll join me on the Steampunk Physics project. So I believe in edutainment. I love to entertain if I can, and instead of just boring people. I hope that I haven't bored anybody here that's been watching. I know sometimes I can sound a little bit droning. I know my voice is getting a little torn up here, but the idea is that edutainment, entertainment, it lifts. It allows you to have the suspension of disbelief, and I think that as we bring these things to people that are new concepts, if they can suspend their belief long enough to just enjoy the concepts, enjoy the imagination, then that can allow them to examine it and ask questions. What I'm asking for is not for physics to be just one particular way. What I'm asking for is for all of this bubbling up that's happening in the background of the ether and of hydrodynamics, of this perspective that's old but has been made new. This neoclassical perspective is just looking at it and developing it and investigating it as a science. So I've got some videos here at the Steampunk Physics. Hopefully that's how you got here, of course. And I do have a little video series that was a pilot that I started that I did I thought that Gaia might pick up, but eventually I just sort of left it alone. But that's 3S, and it's to try to talk about this from more just directly spiritual perspective and not as much with the hard science perspective that I'm trying to do here. Unfortunately, for the past 15 years, I've been working too hard at trying to get everybody, coordinated, and so I haven't actually finished my book. I've been working on preparing a way for all this information so that people could absorb it, digest it, look at it, and actually begin to investigate it. But that book is nearly finished. I've actually tried to kind of do two books at once, both the spiritual perspective and the scientific perspective. If you would sign up to my newsletter, I would appreciate it, because that way I can keep you informed. Once that book comes out, I'll let you know, and I'm not going to spam your I don't like spam. I'm not going to allow spam to occur. So if you'll give me the trust of your email address, I'll make sure to be careful about what I send your way. And the name of my book, tentatively, is A Neoclassical Interpretation of Modern Physics, The Return of Ether. So look for that coming up fairly soon. And I hope you'll continue to join me as I try to get more interviews going on this channel. You should check out my interview with Jess Brewer. He's a great fellow, really fun to talk to. And so I've got at least one physicist publicly saying that what I'm saying is not crazy. There's a lot in private who are saying that's not crazy, but I hope you'll enjoy that, and I hope you'll continue to come with me on this journey, and I hope you'll support this journey. I hope you'll tell other people about it, and that there is this other perspective that may support an entirely mechanical, deterministic, engineering based perspective on what the spirit world is, and that there is this, and that's, I guess I do need to say, I hope some people haven't skipped over this part, because I do need to finally say that this computing substrate out there could actually hold entire other worlds like any kind of computing substrate could. And the question then is, does it? Is there this whole other world that we're just at the edge of? Is this whole other extremely complex world that's got way more going on inside it than our little edge of the universe has going on in it? That's the question. And I think a lot of you already have your answer. You already know what the answer to that is. But for those of us in engineering, et cetera, we're going to have to investigate a lot. There's going to have to be a lot done. There's a lot of work to do. But I think that so long as we start looking at it, the work will get done. And I think that can lead to a tremendous revolution. So join me in the neoclassical revolution and in my steampunk physics project. Thank you so much.